through these. Please do them. The definition of a parabola is a set of all the points in a plane that are the same distance from a given point, called a focus, and a given line called a directrix. Parabolas are what we call conic sections. All of the figures we're working with in this chapter are conic sections. They're called conic sections because if you take a plane and slice a cone, you form either a parabola, an ellipse, a hyperbola, or a circle, depending on your plane. We have already, like I said, talked about parabolas that are in the form of y is equal to a times x minus h squared plus k. Those are parabolas that face up or down. So if it's in that form, they face up or down, they are considered a function. If it's in the form of x is equal to a times y minus k squared plus h, it is a parabola that faces left or right, and it is not a function. Now, if it starts with y is equal to, maybe remember that y is equal to looks like a parabola that faces up. Whereas if it is x is equal to, if you draw that x, it could face left or right. So hopefully that's a way to remember which way they face. Next I have a chart. This chart is in your textbook on the different parabolas. You'll notice here once again we have y is equal to a times x minus h squared plus k. That is a parabola that faces up or down. If a is a positive number, it faces up. If a is a negative number, it faces down. We found the axis of symmetry to be x is equal to h. And we found the vertex to be h and k. The focus for this is h and k plus 1 over 4a, and the directrix is y is equal to k minus 1/4 or 1 over 4a. I will not ask you to remember these two forms. I'm not asking you to remember them. If you need them, I will give them to you. But like I said, most of the problems that I picked out on tonight's homework are problems that are parabolas that face left or right. They're in the form of x is equal to a times y minus k squared plus h. When a is a positive number, they face right. If a is a negative number, they face left. The axis of symmetry, look inside the parentheses, and you will find the axis of symmetry is y is equal to k. The vertex, though, is a little tricky because it remains h and k. And then the formula for the focus and the directrix are up here as well. These are not functions. Parabolas that face up or down are functions, and parabolas that face left or right are not. So the first example that I have up here, you're asked to put the equation in the vertex form. That is in the form of x is equal to a times y minus k squared plus h. We want to put it in vertex form. Like I said, we've been doing this since chapter 6. We want to group the first two terms together. So you have x is equal to y squared plus 14y and we're going to complete a square. Since we're working on the same side of the equation, instead of adding 49 here and then adding it over here, we're just going to subtract it. So because we're working on one side of the equation, we're going to subtract 49, and then we'll rewrite this as x is equal to y plus 7 squared minus 29. Once again, you want to look inside of the parentheses to find the axis of symmetry. It is y is equal to negative 7. Then you want the vertex. You need to be careful. The reason I asked you to write y is equal to negative 7 so that you know that negative 7 goes in y's place for the vertex, and negative 29 goes in x's place. It is a parabola that opens to the right because a is a constant number. Our next example is a little bit trickier. Notice here I have one squared term. Parabolas only have one squared term. And so if it has one squared term, you know it's a parabola. We want to get the squared term and any of the other variables that are the same on the same side of the equation. We want the variable that is by itself on another side of the equation by itself. So we have 3x is equal to y squared plus 8y plus 31. Now we can divide by 3, but we're stuck with a bunch of fractions. It would probably be easier to divide by 3 at the end instead of here. So, first thing we want to do, like we did before, is group the first two terms. We want to take half of a and square it. We'll add 16 on the inside, but don't forget you're subtracting 16 on the outside. Then we'll factor to get y plus 4 squared is equal to 15. Sorry, plus 15. Y plus 4 squared plus 15. Now we want to divide by 3, but we want to divide everything by 3, so we have y plus 4 squared divided by 3 and 15 divided by 3. So what do we have? We have x is equal to 1/3 times y plus 4 squared plus 5. The axis of symmetry is y is equal to negative 4. The vertex is negative 4 and 5, or is it 5 and negative 4? 5 and negative 4. Because this is y is equal to negative 4, it needs to go in y's place. So it is y is equal to negative 4, so it needs to go in y's place. And then the direction of opening is to the right, because a is a constant. two terms. We want to factor out a 5. Remember, we're going to subtract 5 times whatever we're putting there. The 1/2 of 5 squared is what? So we got 25 fourths. So we're going to add 25 fourths. So we have x is equal to 5 times y plus 5 halves squared plus 240 fourths minus 125 fourths. We have x is equal to 5 times y plus 5 halves squared plus 115 fourths. The axis of symmetry is y is equal to -5 halves. The vertex, once again, you need to be careful. It is 115 fourths and -5 halves. And it opens to the right. If A is a positive number, it opens to the right. If A is a negative number, it opens to the left. Okay? I don't know which homework exercises are like this, but some of the homework exercises give you a focus. And a directrix. Ask you to write equations. So I think what we'll do is we'll write the equation first, and then I'll go back and talk about what a focus is. To work a problem like this, you basically want to say x minus a minus 4 squared plus y minus a minus 2 squared is equal to x minus a minus 8 squared. The definition of a parabola is based on the fact that there is a focus and a directrix, and it's really about the distance. But up here, you'll notice on one side of the equation, I have x plus 4 squared and plus y plus 2 squared. On the other side of the equation, I have x plus 8 squared. The ones that are alike, you should FOIL. The one that is by itself, you should read just how it is. So if you FOIL this, you get x squared plus 8x plus 16. Leave y plus 2 just how it is. And square this and you get 8x squared plus 16x plus 64. You then want to simplify this. So you'll subtract x squared from both sides of the equation. Then if you subtract 8x from both sides of the equation, you get y plus 2 squared plus 16 is equal to 8x plus 64. We'll remove the constants to the other side of the equation, so we're going to subtract 64 4. And when we do, we get y plus 2 squared minus 48 is equal to 8x. So we have 8x is equal to y plus 2 squared minus 48. But we don't want 8x, we want x, so we're going to divide everything by 8. When we do, we get x is equal to 1/8 times y plus 2 squared minus 6. So the axis of symmetry is y is equal to -2. The vertex is at -6 and -2, and it opens to the right. Right, right, okay, right. Right, positive number, it opens to the right. A is a negative number, it opens to the right. Think about it this way, y'all. If you've got an x-axis, you got a positive x here, a negative x here, it's opening this way, a negative positive, facing towards the positive x. If it opens this way, it's facing towards the negative x, so a is negative. Okay? So let me go over one more type of problem that's on homework tonight, and then I'll come back and go over the definition. Where all that comes from. Some of the homework exercises tonight is ask you write an equation given the vertex and the point on the curve. So the first thing you want to do is find A. You would have to have a picture, or at least be able to find or have the directions to get there. So maybe you had a point on the curve. Yeah, you probably could still do it if you got a point on the vertex. Because it opens to the left, we know that A has got to be a negative number. The other thing is, we know that the form will be x equal to A times y minus k squared plus h, which it does open to the left. So we want to take our information. We know that the vertex is 4 and 1, which is h and k. We have a point on the curve, 3, 3, which is x and y. We'll take that information and plug it in the formula and solve for A. So we have 3 is equal to A times 3 minus 1 squared plus 4. So we have 3 is equal to A times 2 squared plus 4. So we have negative 1 is equal to 4A. So A is equal to negative 1, 4. Once you have A, you want to take A, plug it back in the function. A. Put it in the formula with the vertex. So the formula was x is equal to negative 1 fourth times y minus 1 squared plus 4. But now have equations point on the curve x equals 3. Okay. I think the thing is the problem. So let's go back to this. So once again, let's say you're given a focus of 2, 3, and you're given the directrix y is equal to -1, and you're asked to write an equation. Well, I've showed y'all how to do that, but I want y'all to see why it is what it is. If we plot the focus, which is 2 and 3, we have, we'll call that focus. And we have the directrix, which is a line, a horizontal line, y is equal to -1. The definition of a parabola says it is the set of all the points in the plane that are the same distance from a given point called the focus and a given line called the directrix. So what that means is if we drew the parabola correctly, this is not the best, that the distance from this focus to the vertex is the same as from the vertex to this. It also says in that definition that any point on this curve, if we draw a line from that focus to any point on the curve, this distance is the same as that distance. I realize my picture's not very good and it doesn't look that way. So what that means is if we find this distance, we call this x y. Find that distance, it would be x minus 2 squared plus y minus 3 squared. That equals the distance. And this point right here is still x and y is -1. So this distance is equal to x minus x squared plus y minus 1 squared. And those two distances the distance from here to here, if the picture were drawn correctly, is the same as the distance from here to here. This point on the curve is x and -1. I don't care what x is. They're the same x. So the distance formula says x minus 2 squared plus y minus 3 squared. The square root of that is the distance from here to here. The distance from here to here is the square root of x minus x squared plus y minus the minus 1 squared. So if you square both sides to get rid of the radical signs, you have x minus 2 squared plus y minus 3 squared is equal to, well, what's x minus x? So you don't even need that one, or this one. So you have y plus 1 squared. Once again, you want to FOIL the two that are alike and leave the one that's a single by itself. So if we FOIL this, we get x minus 2 squared plus y squared minus 6y plus 9 is equal to y squared plus 2y plus 1. If you subtract y squared from both sides, we don't have any y squared. So now we have x minus 2 squared minus 6y plus 9 is equal to 2y plus 1. Then I would add 6y to both sides of the equation. And subtract 1. So I get x minus 2 squared plus 8 is equal to 8y. We then need to divide by 8. So you're dividing each one of these by 8. And you get y is equal to 1/8 times x minus 2 squared plus 1. That is the equation for that parabola that has a focus of 2, 3 and a directrix of